東京電力ホールディングス福島第一廃炉推進カンパニーリスクコミュニケーターの木本と申します。私からは福島第一の現状についてお話しいたします。福島第一原子力発電所は2011年3月11日大きな地震と津波の影響で当時運転していた1、2、3号機の冷却機能を失ってしまい、その後原子炉の燃料が溶融し、そこから発生した水素によって1号機と2号機、また3号機とつながっていた4号機が水素爆発に至りました。事故の影響で近隣の住民の方々をはじめ多くの方に避難を強いることとなり、今ど多くの方々に大変なご迷惑をおかけしております。その後、国や自治体その他多くの方々のご支援をいただきながら事故の収束作業を進めているところです。福島第一の廃炉作業は非常に長期にわたります。当社としてはこの福島第一の廃炉作業に加えて地域の復興、この両立を目指しています。事故を起こした1から4号機の今の様子です。1号機の建屋からだいたい80メートルぐらいの距離にいますが、特別な装備なしにこちらにいることができます。それは作業環境を改善をして放射性物質を含んだダストを抑制しているからです。ですけれども空間線量としては非常に高い場所ですので、建屋近傍で作業する際には事前に計画を立てて時間をしっかり管理をすることで被爆線量としては国内の法律に収まるようにしています。福島第一の廃炉作業にはまだまだ課題があります。国と定めている工程表に基づいて定められたマイルストーン一つ一つをクリアしてきました。それでは福島第一の今の様子を現場の映像とともにバーチャルツアーでご紹介したいと思います。
We've just entered the Fukushima Daiichi nuclear power station. Through inside Fukushima Daiichi, you'll be able to access places at the Fukushima Daiichi nuclear power station where most are not allowed, and see what's happening in the field on the front lines of decommissioning. The people that work at the Fukushima Daiichi nuclear power station call it 1F. This area has been decontaminated, thereby allowing workers to walk around in basic work clothes. The trees on the right are cherry blossoms. Prior to the accident, there were approximately 1,000 cherry blossom trees that many people came to see during the blooming season. Unfortunately, many needed to be cut down as decommissioning work progressed. There are only a few left now, but they still bring a sense of calm to the workers on site. This bustling intersection connects the entrance to 1F with the decommissioning site. It is affectionately called the friendly intersection because almost everyone who works at the site goes through it. If we go a little further, we will finally reach the decommissioning site. Let's go in. Cars affixed with red stickers had their radiators contaminated by radioactive substances during the accident and have since therefore been used as on-site vehicles at the power station. The license plates had been removed to prevent the vehicles from being used off-site. Now that the site has been decontaminated and the risk of contamination by radioactive substances has been reduced, we ceased use of these on-site vehicles in October 2020. We have also started to procure vehicles with license plates that can be used off-site as well as on-site. This is the on-site gas station. The underground tanks allow vast quantities of gasoline and diesel to be stored and also enable use of the facility during an emergency. Furthermore, in order to achieve a carbon-neutral society, we are proactively replacing company cars with electric vehicles, and even at the Fukushima Daiichi nuclear power station, an EV bus with a custom vinyl wrap has been in service since January 2023. On Guide Route 3, we will go to high ground, from where we can see Units 1 through 4. At the time of the accident, all workers were required to wear protective clothing and full face masks in all areas of the site. However, as a result of dust dispersion prevention measures and decreases to radiation levels, 96% of the site can now be accessed wearing simple masks and general-purpose work clothes. We have arrived at high ground, approximately 100 meters away from the Unit 1 through 4 reactor buildings. There is no need to wear radiation masks or gloves, and we can view the buildings from on the hill wearing normal clothes, as you can see. We will move steadily forward with decommissioning while prioritizing safety. On Guide Route 4, we will show you the current conditions at Unit 1. The top part of the Unit 1 reactor building was severely damaged during the accident by a hydrogen explosion. In order to remove fuel from the spent fuel pool, we must remove rubble from the top of the reactor building, which hinders this task. We are currently in the process of constructing a large cover to prevent the dispersion of dust and the influx of rainwater during the rubble removal process. The construction will be completed in the summer of 2025. In order to reduce worker exposure dose, pre-assembly is being performed in areas where radiation levels are low, and then the assembled steel frames will be brought to Unit 1 on a remotely operated supercarrier, where it will then be assembled. Internal investigations of the primary containment vessel are being conducted in preparation for fuel debris retrieval. On Guide Route 5, we will show you the current conditions at Unit 2. The side panels at the top of the Unit 2 reactor building were blown open by the shock of the hydrogen explosion at Unit 1. This allowed hydrogen to escape the building, thereby avoiding a hydrogen explosion at Unit 2. The panels are currently closed, and construction of a platform alongside the reactor building is underway to remove fuel from the spent fuel pool. We will remove fuel applying a safer method that can further prevent the dispersion of dust. The construction of the platform will be completed in fiscal year 2024. Fuel debris retrieval is planned to begin with Unit 2. Previous internal investigations have proven that deposits can be grasped and moved. We will retrieve a small amount of fuel debris on a trial basis and have it analyzed by expert agencies. We opened a penetration hatch of the primary containment vessel in October 2023 and commenced deposit removal work inside the penetration in January 2024 for fuel debris trial retrieval. We will use the telescoping device that was successful during past internal investigations. Thereafter, we will perform internal investigations and retrieve fuel debris with a robotic arm. We will continue this task while prioritizing safety. On Guide Route 6, we will show you the current conditions at Unit 3. During the accident, a hydrogen explosion occurred at Unit 3. We completed removal of all 566 fuel assemblies in the spent fuel pool after we had finished the removal of the rubble from the operating floor of the reactor building, thereby eliminating risks associated with that nuclear fuel. During an underwater investigation conducted in preparation for fuel debris removal, structures and deposits assumed to be melted were observed. On Guide Route 7, we will show you the current conditions at Unit 4. During the accident, hydrogen generated at Unit 3 flowed through pipes into Unit 4 and caused a hydrogen explosion. Since the reactor had been shut down for periodic inspection, all the reactor fuel was in the spent fuel pool. The removal of this fuel was completed in December 2014, thereby eliminating risks associated with this nuclear fuel. This is the road leading to Units 2 and 3. A gray slope can be seen on both sides of the road. This is the product of facing work, which entails spraying mortar over the ground to cover the surface. By facing surfaces in this manner, we can largely suppress the dispersion of dust that contains radioactive substances, thereby lowering site radiation levels. This in turn allows workers to engage in their duties wearing normal work clothes without the fear of clothing contamination. Facing surfaces in this way prevents rainwater from seeping into the ground, thereby reducing the amount of groundwater flowing into buildings. Let's get closer to the reactor buildings. As we approach, you can see Unit 2 on the left and Unit 3 on the right. You can see many workers in this area engaging in decommissioning work, while radiation levels are closely watched. Let's take a closer look at each reactor building. At Unit 2, preparations are underway to remove fuel from the spent fuel pool. To apply a safer method that can further prevent the dispersion of dust, we are constructing a platform for removal of the spent fuel. This is the side of Unit 3 as seen from Unit 2. At Unit 3, much of the damage from the accident can still be seen, but work is steadily being implemented while considering safety. On Guide Route 10, we will head over to Unit 5. As you can see, Unit 5 suffered little damage from the tsunami because it is located at a higher elevation. The reactor is currently shut down and fuel is being stored cool and safe in the spent fuel pool. Units 5 and 6 will also be decommissioned. We have just entered the Unit 5 reactor building. We are on the path that circles the outside of the containment vessel, indicated by the yellow arrow on the diagram. The orange circular entrance and wall that you see on the screen is the containment vessel. And inside that is the reactor pressure vessel. Let's look around the entrance to the containment vessel. Now let's go inside the primary containment vessel. The Unit 5 containment vessel is similar in construction to the containment vessels of Units 2 through 4, so it is being used to deliberate fuel debris removal. Prior to conducting an internal investigation of the Unit 2 containment vessel, a robotic arm was taken along the route you are viewing to examine conditions. We have now reached the center of the containment vessel. The space inside is too small for a person to stand up. We are now directly beneath the reactor pressure vessel. Going forward, we will safely and steadily continue preparations for fuel debris removal. In this part of the tour, we will show you the investigations being conducted in preparation for fuel debris retrieval. Fuel debris refers to fuel and other substances that melted during the accident and then cooled and re-solidified. In order to retrieve this fuel debris, we have to ascertain the conditions inside the primary containment vessel, which is why we are performing investigations. At Unit 1, we have been conducting internal investigations of the primary containment vessel using a submersible robot since February 2022. As a result, we have learned, for example, that there are various types of deposits inside the primary containment vessel, and that pedestal rebar is exposed. From the results of assessment of structural strength, we assessed that it would not result in large-scale collapse by bearing excessive weight, even in the event of an earthquake with greater magnitude than the Great East Japan earthquake, and the impact on the surrounding environment would be minimal, even if the pedestal loses support. We also plan to conduct investigations of non-submerged areas inside the primary containment vessel using a drone to ascertain the overall conditions. In February 2019, we conducted the very first contact investigation at Unit 2, during which we touched deposits in order to examine hardness and brittleness. Using a robot, we grabbed deposits that have accumulated at the bottom of the primary containment vessel, and also confirmed the shape and size of deposits and whether they can be moved. Simultaneously, we measured radiation levels and the temperature of cooling water and confirmed that the inside of the reactor is being kept cool. We will retrieve a small amount of fuel debris from Unit 2 on a trial basis and have it analyzed by expert agencies. We are currently performing tests at a facility in Naraha Town, Fukushima Prefecture, on a robotic arm that will be used to retrieve fuel debris. In parallel with the robotic arm tests, we opened a penetration hatch of the primary containment vessel in October 2023, which serves as the entry point for the robotic arm, and commenced deposit removal work inside the penetration in January 2024. For the trial retrieval of fuel debris, we will first use a telescoping device that was successful during past internal investigations and ascertain the properties of fuel debris as soon as possible. The robotic arm will be used for internal investigations and retrieval of fuel debris following the work performed by the telescopic device. Therefore, we will continue to improve safety and operability of the robotic arm. At Unit 3, devices such as an underwater camera were used to conduct similar investigations due to the vast amount of water present inside the primary containment vessel. We were able to obtain video of molten material deposits and confirm temperature and radiation levels inside the primary containment vessel. This has shown that, like Unit 2, Unit 3 is being kept cool. We will continue to prepare for fuel debris retrieval step by step. On Guide Route 13, we will take a look at the main control room for Units 1 and 2. It is currently not in use, but prior to the disaster, it was used to monitor and operate the reactors and turbines, and also control radiation. During the accident, this main control room was the front line for operators desperately trying to keep the situation under control. Numbers written on the control panels during the accident can still be seen today. This is a note about cooling water levels that were being recorded in order to confirm that the reactor was being cooled. The unsteady hand of this information written directly on a control panel in pencil shows how nervous operators were as they responded to the accident in the dark. This is the common exhaust stack that was used to ventilate Unit 1 and Unit 2. In May 2020, we completed dismantling approximately half of the exhaust stack in cooperation with a local company. This exhaust stack had sufficient seismic resistance, but we found areas that were damaged during the accident. Therefore, in order to prevent the exhaust stack from collapsing in the future due to aging, we used a dismantling device developed by a local company to dismantle the top approximately 60 meters of the stack. Furthermore, in order to reduce worker exposure during dismantling, we converted a large bus into a remote operations center approximately 200 meters away from the exhaust stack. As you can see, pictures have been drawn on the outside of the bus. These are illustrations drawn by children whose mothers and fathers were engaged in this task. They were drawn to express their support for their parents' work and are one source of motivation for everyone involved in decommissioning. Furthermore, we completed removing the standby gas treatment system pipes with local companies that were connected to the Unit 1 and 2 exhaust stack. As a result of the accident, these pipes were extremely radioactive and had to be removed because they had hindered work in the vicinity. Going forward, we shall continue decommissioning work while minimizing worker exposure and prioritizing safety. On Guide Route 15, we will talk about the current state of fuel removal from the spent fuel pools. Fuel is being removed from 1F in 3 steps. Firstly, the fuel is put into an on-site transport container while it is still in the pool. This on-site transport container is then transported using a dedicated vehicle to the common pool building. The fuel is then stored in the common pool. Let's take a look at Unit 3, where the removal of fuel from the spent fuel pool had begun in April 2019. This is the uppermost floor of the reactor building, as seen from underneath the domed roof cover. Here we can see the fuel handling machine. A total of 566 fuel assemblies had been stored in the Unit 3 spent fuel pool, but in February 2021, we completed removal of all the fuel, thereby eliminating risks associated with this fuel. We commenced the removal of control rods, etc., that have high doses and remain in the spent fuel pool in March 2023, and have been conducting the work. The removed fuel is being stored safely in the on-site common pool. Spent fuel continues to emit radiation and heat. Therefore, it is stored in water, which acts to both cool the fuel and shield the radiation. In addition to the 566 fuel assemblies removed from Unit 3, 1,535 fuel assemblies removed from Unit 4 are also being stored in this common pool. In Unit 2, construction of a platform for spent fuel removal is underway and will be completed by fiscal year 2024. As soon as preparations have been completed, fuel will also be removed from Unit 1. We are currently in the process of constructing a large cover and will complete this work in the summer of 2025. We will continue this task while prioritizing safety. Guide Route 16 will take us to facilities used to prevent the generation of contaminated water. Contaminated water is generated when groundwater seeping into the buildings for Units 1 through 4 comes in contact with radioactive substances. Various countermeasures are being implemented to prevent the generation of contaminated water. Groundwater flowing down from the mountains is pumped up using wells that comprise a groundwater bypass. And groundwater flowing near the buildings is pumped up using subdrain wells. The landside impermeable wall is a wall created by freezing soil under the ground to decrease the amount of groundwater flowing near the buildings. As a result of these and other countermeasures, the amount of contaminated water being generated has been reduced from 400 to 500 cubic meters per day immediately after the accident to approximately 90 cubic meters per day in fiscal year 2022. Let's take a look inside the freezer plant. In the freezer plant, the temperature of the landside impermeable wall is monitored 24 hours a day. Workers you can see in the distance are checking the operation status of equipment. This monitor is used to confirm that the temperature of the landside impermeable wall is being kept at the appropriate level. Let's go take a look at the freezer room in which the equipment for actually keeping the wall frozen is located. On Guide Route 17, we will look at the tanks used to store water, such as Alps treated water. As of January 2024, there are more than 1,000 tanks on site with the capacity of approximately 1.37 million cubic meters of water. Double dikes have been constructed around the tanks to contain any water in the event of a leak. Water levels are continuously monitored and inspection patrols are regularly conducted to ensure that we are prepared to immediately respond to any leaks if they were to occur. Did you notice the tents set up around the tanks? These tents have been set up to prevent rainwater from entering the dikes. If there is a water leak, this would enable us to accurately measure and analyze the amount of water that leaked. On Guide Route 18, we will give you an overall explanation of the facilities used for discharging Alps-treated water into the sea and their operation that began on August 24, 2023. What you are looking at is the building that houses multinuclide removal equipment and the measurement confirmation facility. Alps-treated water that has been purified with multinuclide removal equipment, etc., is first transferred to the measurement confirmation facility. In this facility, the concentrations of radioactive substances are measured to confirm that they meet the government's regulatory standards, excluding tritium. This confirmation process is conducted not only by TEPCO, but also an outside agency commissioned by TEPCO, and a third party based on the Japanese government's basic policy. Alps-treated water that has been confirmed will pass through the pipes designed to reduce the risk of leaks, and which are currently being constructed, to dilution facilities built near the sea. At this dilution facility, Alps-treated water is mixed with a large volume of seawater taken in from outside the port. Alps-treated water has been diluted with seawater more than 100 times and then transferred to the discharge vertical shaft. After that, it passes through a discharge tunnel and is discharged from a discharge outlet approximately 1 kilometer offshore. During discharge, we confirm that there are no safety issues by monitoring tritium concentrations calculated from the dilution ratio continuously and measuring the concentrations in discharging water daily. Furthermore, we will measure the tritium concentration in water in the vertical shaft prior to discharge once a year. This is the room where we operate and monitor the discharge into the sea. The key switch has a lid to prevent unintended discharge. 2 operators carefully operate with mutual confirmation.
移送許可キースイッチオンにしました。移送許可キースイッチオンにした。
Discharging Alps-treated water into the sea, which is a part of the decommissioning process, will be a long-term initiative. We will carefully engage in each step while prioritizing safety. On Guide Route 19, we will head over to the facilities for treating contaminated water. During the ride over to the facility, we will explain how contaminated water generated at Units 1 through 3 is treated. First, cesium and strontium, which account for most of the radioactive substances in contaminated water, are removed using cesium adsorption apparatus. After that, the water is run through a desalination system to remove salt, and then reused as cooling water to cool fuel debris. Contaminated water not used for cooling purposes is purified with multinuclide removal equipment. By subjecting the water to pre-treatment processes and passing it through multiple adsorption towers, we reduce the concentrations of 62 radioactive substances and then store it in tanks. Let's now have a look at multinuclide removal equipment facilities. The equipment you see contains adsorption filters that remove radioactive substances. Multinuclide removal equipment can reduce the concentrations of 62 of the radioactive substances present in contaminated water by adsorbing them one after another. The treated water that has been run through these filters is analyzed without exception, and the analysis data is posted on TEPCO's website. On Guide Route 20, we will give you information on the measurement confirmation facility, which is the closest to multinuclide removal equipment. ALPS treated water that has been purified with multinuclide removal equipment, etc., is first transferred here, where the concentrations of radioactive substances in ALPS treated water are measured and confirmed. The measurement confirmation facility is comprised of 10 tanks for each group and has a total capacity of 30,000 tons. Here, the three operations of 1. Receiving ALPS treated water, 2. Measuring and confirmation, and 3. Discharge are carried out by each group one at a time in turn. 1. Receiving ALPS treated water. Firstly, water treated with multinuclide removal equipment, etc., will be put into these tanks. 2. Measuring and confirmation. Concentration of radioactive substances in the received water will be measured and assessed. Agitators installed in each tank and circulation pumps connected to all 10 tanks are used to circulate the water in the entire tank group to make the water quality homogeneous. After that, the water is analyzed. Prior to discharge, ALPS treated water is measured for the concentration of tritium. Also, the radioactive substances excluding tritium are measured to ensure that they meet the government's regulatory standards for discharge into the environment. This confirmation process is conducted not only by TEPCO, but also an outside agency commissioned by TEPCO, and a third party based on the Japanese government's basic policy. 3. Discharge. ALPS treated water that has been measured and confirmed will then be transferred from this tank group to dilution facilities. On Guide Route 21, we will provide information on the ALPS treated water dilution facility and discharge facility. ALPS treated water in which it has been confirmed that the concentrations of radioactive substances excluding tritium have met the government's regulatory standards for discharge into the environment is then transferred from the measurement and confirmation tank to the dilution facility built near the sea. At this dilution facility, ALPS treated water is mixed with a large volume of seawater taken in from outside the port, so that the tritium concentrations are well below the government's regulatory standards. Seawater is pumped up by the newly installed seawater transfer pumps and sent to the seawater pipe header through seawater transfer pipes. At this seawater pipe header, ALPS treated water is mixed with a large volume of seawater. Flow rate of ALPS treated water is controlled depending on tritium concentration in ALPS treated water, so that tritium concentrations are less than 1,500 becquerel per liter. This is 1/40th that of the government's regulatory standards, and 1/7th that of the drinking water guidelines stipulated by the World Health Organization. Flow meters are continually used to monitor ALPS-treated water and seawater, and if an abnormality is detected, emergency isolation valves will automatically close, thereby terminating sea discharge. Emergency isolation valves have been installed in 2 locations, just in case one does not work. Furthermore, one of the emergency isolation valves has been installed inside of the seawall, so that sea discharge can be stopped even in the event of a large tsunami. ALPS-treated water that has been sufficiently diluted with seawater is transferred to the discharge facility. The water passes through the discharge vertical shaft and a discharge tunnel and is discharged from a discharge outlet approximately 1 kilometer offshore. During discharge, we confirm that there are no safety issues by monitoring tritium concentrations calculated from the dilution ratio continuously and measuring the concentrations in discharging water daily. Furthermore, we will measure the tritium concentration in water in the vertical shaft prior to discharge once a year. Here is a high ground where you can look at ALPS-treated water dilution and discharge facilities when you visit the power station. The shield machine that was used to excavate the discharge tunnel and an actual segment from one of the tunnel walls are on display here. Discharging ALPS-treated water into the sea, which is a part of the decommissioning process, will be a long-term initiative. We will carefully engage in each step while prioritizing safety. On Guide Route 22, we would like to tell you how radioactive substances in the sea areas around the Fukushima Daiichi nuclear power station are being monitored. TEPCO is measuring the concentrations of radioactive substances in seawater and marine organisms in order to evaluate the impact on the environment in the sea area surrounding the Fukushima Daiichi nuclear power station. Since April 2022, before the discharge of ALPS-treated water, we have strengthened and expanded the monitoring of radioactive substances, including tritium, in the vicinity of the power station and the Fukushima coastal sea area. Furthermore, we have also performed sea dispersion simulations of the discharge of ALPS-treated water, and confirmed that tritium concentrations will fall well below the drinking water guidelines stipulated by the World Health Organization. We used the results from this sea dispersion simulation to assess the degree of impact that the radiation will have on humans, animals, and plants. As a result, we have confirmed that dose levels fall well below dose limits stipulated by the government, and also dose limits for each species specified by international agencies. The IAEA confirmed these results and noted the discharge of ALPS-treated water would have a negligible radiological impact on people and the environment. Sea area monitoring results conducted after the beginning of ALPS-treated water discharge into the sea on August 24, 2023, show that tritium concentration is below the drinking water guidelines stipulated by the World Health Organization, the same as the dispersion simulation, and within the historical range for seawater across Japan. We are also conducting quick tritium measurement in the vicinity of the discharge outlet to respond quickly in case of abnormality, in addition to normal measurement. In this measurement, the process is shortened to quickly ascertain any operational abnormalities in tritium concentrations. Monitoring is implemented by TEPCO, as well as by Fukushima Prefecture, the Ministry of the Environment, the Nuclear Regulation Authority, and the Fisheries Agency. The results are being disclosed and disseminated on our website, Overarching Radiation Monitoring Data Browsing System. In this facility, marine organisms such as flounder and abalone are being reared in seawater to which ALPS treated water is added. Since March 2022, we have practiced the rearing of flounder using seawater from around the power station, and in September 2022, we commenced full-scale rearing tests. By performing marine organism rearing tests, we would like to convey the safety of discharging water in a visible manner. Rearing tests are being performed in seawater to which ALPS treated water is added, and in normal seawater. Marine organisms are being reared in both environments, and the concentrations of tritium in these organisms and their growing conditions are being compared and analyzed. Rearing test conditions and data are being conveyed via our website, live web cameras, and a daily rearing log on social media. Furthermore, during flounder rearing tests, we have found that the concentration of tritium in the flounder does not exceed that of the seawater they are reared in, to which ALPS treated water is added, and that the concentration keeps approximately the same as the surrounding seawater after a certain period of time. Thereafter, when the flounder are returned to normal seawater, as time passes, the concentration of tritium in the flounder decreases. Based on these results, we think that tritium is not accumulated or concentrated in flounder. The rearing test results also confirmed that the tritium does not accumulate or concentrate in abalone and seaweed, as well as flounder. On Guide Route 24, we take a look at the Chemical Analysis Building. In this facility, we perform analyses of seawater sampled from inside and outside of the power station port, groundwater, and water that has been treated with multinuclide removal equipment, etc., and is currently stored in tanks. All of this analysis data can be found on TEPCO's website. In order to improve the reliability and technical capability of analysis work, the Chemical Analysis Building has acquired ISO 17025 certification, which is the international standard for analyzing cesium and tritium. We will continue to perform accurate analyses while safely moving forward with decommissioning. What you see before you is the Japan Atomic Energy Agency's Facility for Analysis and Research of Radioactive Materials, Laboratory 1. JAEA is Japan's only comprehensive research and development agency for nuclear power. At this facility, which is located within the Fukushima Daiichi nuclear power station site, waste generated at the Fukushima Daiichi nuclear power station is being analyzed and researched in order to steadily move forward with decommissioning. Therefore, this facility is equipped with devices to perform various analyses while reducing worker exposure, such as steel cells, glove boxes, and fume hoods. The analysis of radioactive substances contained in ALPS-treated water is also performed at this facility, based on the government's policy. Objectivity and transparency is improved by having not only TEPCO, but also third parties perform analyses. On Guide Route 26, we will tell you about our natural disaster countermeasures. What you see before you is excavation work underway to construct Drainage Channel D, which is one of our torrential rain countermeasures. We are currently paving site surfaces, or facing, at the Fukushima Daiichi nuclear power station in order to reduce dose levels. The paving of site surfaces, however, prevents the water from seeping into the ground. As a result, rainwater may accumulate around Unit 1 during torrential rains, which could lead to equipment malfunctions or hinder emergency responses. Therefore, up until now, the influx of rainwater has been prevented by piling up sandbags around the reactor building. We have extended drainage channel D with a tunnel in order to more efficiently prevent the influx of rainwater. As a result, rainwater falling on the west side of the power station now bypasses the Unit 1 area and flows into the port. The construction was finished, and the new system, which can handle even approximately 120 millimeters per hour of torrential rainfall, was put into operation in September 2022. Let's now talk about our tsunami countermeasures. What you see before you is construction on a seawall. In September 2020, we constructed a seawall of approximately 11 meters above sea level because it was estimated that the maximum height of a tsunami caused by an earthquake in the Chishima-Kamchatka Trench could reach a maximum height of 10.3 meters. However, thereafter it was newly estimated that a tsunami caused by an earthquake in the Japan Trench could reach a maximum height of 11.8 meters, which would exceed the height of this wall. Therefore, we are now in the process of constructing a seawall with a maximum height of 16 meters above sea level in order to prevent a tsunami from breaching the site. This construction is expected to be completed during fiscal year 2023. On Guide Route 27, we will head over to the main anti-earthquake building. The main anti-earthquake building we are heading to is the location of the Emergency Response Center used to respond to a nuclear accident. The facility contains conference rooms, communications equipment, power generators, air conditioning equipment, etc., that would enable an unhindered response to an emergency, even if we are struck by a magnitude 7 earthquake. The Emergency Response Center established during the accident was set up here. Have a look at the Emergency Response Center. Vests with various roles written on the back have been laid over the backs of each chair, so we know where each person needs to sit in the event of an emergency. Ongoing teleconferencing with multiple locations, such as TEPCO's head office and the Fukushima Revitalization Headquarters, enables information to be shared on a daily basis. And the status of reactor cooling and the discharge of ALPS treated water are monitored 24 hours a day. On Guide Route 28, we'll take you to the site of waste facilities that are currently under construction. Here, waste is sorted by type and then either stored safely or incinerated. On the right, you can see the additionally built miscellaneous waste incinerator facility. The additional miscellaneous solid waste incinerator facility has been designed to be able to incinerate combustibles such as felled trees that are being stored. Felled trees that have been fed into chippers are carried to the incinerator by a crane, as you see here. The waste is then incinerated safely while checking monitors that show the conditions inside the incinerator, as well as incinerator temperature. The efficiency of waste processing on site has improved dramatically now that we are able to process felled trees safely. The next structure you will see is the volume reduction facility that has been in operation since February 2024. Rubble and other items from the reactor buildings are crushed using large machinery and put into containers. By crushing this material, we can reduce its volume, thereby enabling more compact storage. On the site right in front of the volume reduction facility, 10 additional solid waste storage facilities will be built in fiscal year 2024. Here, containers filled with waste from the volume reduction facility and containers that are being stored outside will be safely put in storage. Next, you can see the large waste storage facility that is under construction. This will be used to store large, heavy waste, such as used filters from multinuclide removal equipment. The construction of the large waste storage facility will be completed in fiscal year 2025. Lastly, this is the miscellaneous solid waste incinerator facility. Here, gloves, masks, and protective clothing used during decommissioning work is incinerated after being temporarily stored in dedicated containers. We will continue to build additional facilities to enable safe storage and incineration of waste. On Guide Route 29, we will look at the large rest house completed in May 2015. This steel-constructed 9-story building can accommodate approximately 1,200 people. The building is unique. That's right, it only has one small window. It was designed without windows to prevent radiation from entering as much as possible. This large rest house has break rooms, meeting rooms, a cafeteria, a convenience store, and showers, thereby greatly improving the work environment. The warm meals served at the cafeteria, which are made using ingredients grown in Fukushima Prefecture, warm not only the body but also the heart, and provide the energy to get back to work. On the first floor of the large rest house, there are whole-body counters used to measure the amount of radioactive substances inside the human body. Workers measure themselves regularly to accurately ascertain exposure doses. On Guide Route 30, we will look at the new administration office building that was completed in October 2016. Approximately 1,000 TEPCO employees engage in decommissioning duties in the new administration office building. After the accident, these employees worked in the main anti-earthquake building, but now they can work in a more comfortable environment in this newly built 3-story steel-constructed administration office building. Every morning, employees perform radio calisthenics at the new administration office building, after which they head off into the field. With their morale raised, workers can now engage in decommissioning work again today without injury. This is the International Atomic Energy Agency Fukushima Daiichi Nuclear Power Station office. Created in 1957, the IAEA is the world's center for cooperation in the nuclear field and seeks to promote the safe, secure, and peaceful use of nuclear technologies. The IAEA conducted a detailed review of the safety-related aspects of Japan's plans for handling the ALPS-treated water stored at the Fukushima Daiichi Nuclear Power Station, applying the relevant international safety standards. The review was carried out by an IAEA task force, including external experts from Argentina, Australia, Canada, China, France, the Marshall Islands, the Republic of Korea, the Russian Federation, the United Kingdom, the United States, and Vietnam. In July 2023, the IAEA released a comprehensive report that summarizes the reviews. In this report, the IAEA concluded that the discharge of ALPS-treated water into the sea is consistent with relevant international safety standards and will have a negligible radiological impact on people and the environment. At the time of the release of the comprehensive report, IAEA Director General Rafael Mariano Grossi visited Fukushima Prefecture and stated that the IAEA will be there before, during and after the discharge of ALPS treated water. And the IAEA is going to stay here with you for decades to come, until the last drop of the water has been safely discharged, committing to engage with on-site monitoring. The IAEA was present for the commencement of discharge of ALPS treated water on August 24, 2023. The IAEA Fukushima Daiichi Nuclear Power Station office is continuously staffed to support ongoing review missions, corroborate Japan's source and environmental monitoring programs, and continue outreach and awareness activities. In October 2023, the IAEA task force conducted the first review mission after the start of ALPS treated water discharge, and the IAEA released a report on the review in January 2024. In this report, it is noted that the task force did not identify anything that is inconsistent with the requirements in the relevant international safety standards.
福島第一の現状をバーチャルツアーでご覧いただきました。福島第一はまだまだ多くの課題があり、廃炉作業も非常に長くかかります。課題を一つ一つ解決をして、近隣の住民の皆様にこれ以上ご心配をおかけしないよう安全最優先で続けてまいります。今日ご覧いただいた内容から福島第一原子力発電所が事故当時から大きく廃炉作業が進捗していること、ぜひご理解いただきたいと思います。また当社のホームページにはたくさんの資料、またデータも掲載しています。多言語化したページもありますので、ぜひご興味ありましたらご確認いただきたいと思います。